So here we are at Chapter 2, Chemistry and Measurements. You can download your own copy of these lecture outlines and fill them in with me as we go. So chemistry is called the central science because you use chemistry every day all the time. The water and shampoo in your shower, your food, the power for your phone, the life-saving drugs, sunscreen, even your clothes involve chemistry. Chemistry is the bridge between biology and physics. So in this kind of intro course, we get a lot of people who are interested in biology and they wonder why they have to take a chemistry class. Well, chemistry is the foundation, the underpinnings of all the biology you'll take. So when we study chemistry, one of the first things we need to look at is measurements. And we want to look at the units. We're going to be using metric and System International units, the SI units. So length is going to be measured in meters in both cases, and it's abbreviated with a small m. Volume is going to be measured in liters, capital L, or in cubic meters. And that's m cubed. All right, mass is measured in grams, small g, or in kilograms, and that's kg. Temperature is measured in Celsius, degrees Celsius, or in Kelvin. When we do gas laws, we'll do Kelvin exclusively. And temperature is measured in seconds in both cases. So in this section, we're going to talk about measured numbers and exact numbers. So some numbers are exact numbers. These are numbers that we know with complete certainty. There are exactly 3 feet in 1 yard. A square has exactly 4 sides. We know those numbers with complete certainty. But we also have measured numbers. And a measured number, unsurprisingly, is obtained by measuring. And it has an estimated amount. A measured number is dependent on the instrument you use. I can use my bathroom scale and find out that I weigh 100 pounds. My bathroom scale goes to the 10th place. Or I can use a precision balance in the lab and find out that I weigh 100.0000 pounds. Always put units. So a measured number is obtained by measuring, and it also is dependent on the instrument used. And whenever we do calculations with measured numbers, we need to make sure that we record the correct number of digits. We don't want to add digits that aren't meaningful. We want to only record the digits that we really did measure. So in order to make sure we do this correctly, we follow the significant figure rules. So if we have a number and the digit is not 0, or it's a trapped 0, or a trailing 0, we consider it significant. We consider the coefficient of a number written in scientific notation to be significant. So let's look at some examples of these. So a number such as 247.9, we would call that number has 4 significant figures. It has 4 significant figures because they're all non-zeros. We consider a trapped 0, a number that's between 2 non-zero numbers, to be significant. So that would be something like 204 has 3 significant figures. A trailing zero with a decimal, so the number has 3 significant figures, and the number 2.00 with a decimal has 3 significant figures. The coefficient of a number written in scientific notation, well, that's just any number. This is the coefficient. We would say that has 2 significant figures. Now, zeros are not significant if they're at the beginning, or they're like this. 0.001 has 1 significant figure. They're also not significant if there is no decimal at the end. So if I had this number 200, but this time there's nothing in the decimal, there's not a decimal, this also has 1 significant figure. So let's look at some examples so we can figure out what's significant. Determine the number of significant figures in these numbers. Okay, well, this first number doesn't have any zeros, and so all of these digits are significant. So this one has 4 significant figures. This number has a 4, a 5, and a 6. Those are certainly going to be significant. It has a 0 here at the end, but there's a decimal, and a 0 with a decimal at the end is significant, so that's also 4 significant figures. All right, the 5 is definitely significant. The 8 is definitely significant. We have these 4 leading zeros that are out in front, and they will not be significant. Leading zeros are never significant. So this number has 2 significant figures. Okay, the 1 is definitely significant, and then we've got 3 zeros, but we have a decimal, and because we have a decimal, we want to count those zeros. So this number has 4 significant figures. For scientific notation, we have a coefficient with 3 significant figures, so we would expect our number to have 3 significant figures. And here we have only 1 significant figure. We have the 1 is definitely going to be significant, but these trailing zeros have no decimal, and so we only have 1 significant figure. There should be a practice handout. I'm not going to take it up, but it is well worth your time to go and do that handout, because these can be confusing. The rules, until you get used to them, seem a little odd. Okay, so let's look at rounding these measurements off. If we want to round off to 3 significant figures, we'll keep the 1, the 8, and the 5, and lose the 4, and we'll end up with 1.85. If we want 3 significant figures here, the 4, the 3 of the 7, and the 3, when we lose the 8, we're going to make the 3 a 4. So we're going to lose the 8 and the 4, so we'll get 0.00474. It's important to note here that we keep these zeros in the front because they give us place value. We don't want to change our 0.004 into 474 because that wouldn't be equivalent. Okay, so let's look at this one. We're going to need to get 3 significant figures. We'll keep the 2, keep the 3, keep the 9, and then we've got this 8. So if we are going to get rid of the 8, we'll make the 9 a 10. We're going to end up with 240. We need to keep our place value, so we have 3,400. As I've written it here, that has 2 significant figures. If I put a decimal behind it, I'm going to have 4 significant figures. My directions have asked me to do 3 significant figures, so I'm going to write this in scientific notation. 1, 2, 3. And this last one, we will knock off the 2 and we'll get 1.83 times 10 to the 5th. Number 3 here is a little bit tricky to get the right answers down here. All right. The next section we'll look at using our significant figures in calculations.